All right, let's take another example. Let's take a look at this question. Please, I want you to pay attention. Okay, now we have the question that says find the integral of cos x in sin x dx. You get this? Find the integral of cos x in sin x dx. So we're going to make use of integration by part. So this, we're going to make use of the formula that say the integral of u dv is equal to u times v minus integral of v du. All right? Yes. So here, let's try to identify u and then dv. So we can simply say let u equal to in sin x. Let u equal to in sin x. So here, I want us to differentiate this u with respect to x. But before we differentiate this, we are going to apply the chain rule in differentiation. We're going to apply the what? The chain rule in differentiation. So we're going to say let sin x equal to t. Let sin x equal to t. So if we choose sin x to be t, that means in our function u, we are going to have u is equal to in t. Is that true? Yes. Now, in this place we say let t equal to sin x. Let's differentiate this t with respect to x. That means we're going to have the t all over the x is equal to. So the differentiation of sin x is going to give us cos x. So we have the t all over the x is equal to cos x. You know, in our function u, we have u is equal to in t, right? Yes. Let's differentiate u with respect to t. So that means we're going to have du all over t. The t is equal to. So the differentiation of in t is going to give us 1 all over t. All right? Yes. But you realize that what we wanted to find initially is the derivative of u with respect to x. But now we have the value t. So that means we're going to say du all over the x is equal to du all over the t, which we have differentiated, times the t all over the x, which is the chain rule we say we're going to make use of. All right? Yes. And then here we say that du all over the t is equal to 1 all over t. All right? Yes. Times the t all over the x is equal to cos x. But you remember that t is equal to sin x. Let's replace it back now. We're going to say 1 all over sin x times cos x. You get it? So therefore, du all over the x is equal to cos x all over sin x. But we are interested in making du the subject. So if you try to make du the subject, we can simply cross multiply. So when we cross multiply, we're going to say du sin x is equal to cos x du. Cross multiply. Okay? So we want to make du the subject. We can simply divide both sides by sin x. So du sin x divided by sin x is equal to cos x dx divided by sin x. So therefore du is equal to cos x all over sin x dx. You get it right? Yes. And then, let's go back again. After when we say that let one part be called our u, then the remaining part is going to be our what? Dv. So we say dv is equal to, we're going to have cos x dx. All right? Yes. This is the derivative of v. We are interested in the value for v. So that means we're going to integrate. We're going to say the integral of dv is equal to the integral of cos x dx. So the integral of dv is going to give us v is equal to sin x. All right? Yes. We have gathered some values. Let's join them together. In this formula that we say the integral of u dv is equal to u times v minus integral of v du. All right? Yes. So here we're going to say the integral of cos x in sin x dx is equal to, our u now is in sin x multiplied by v. Our v is sin x minus the integral of our v is sin x multiplied by du. Our du is cos x all over sin x dx. All right. Yes, here sine x, we cancel sine x. We'll be left with cos x dx. Okay. So that means we are having the integral of cos x in sine x dx is equal to sine x in sine x minus the integral of cos x dx. So let's just find the integral of cos x, okay? So when we find the integral of cos x, it's going to give us sine x. So therefore, we're going to say that the integral of cos x in sine x dx is equal to sine x in sine x minus sine x. You get it? Yes. And then in this place, as we look closely, we discover that we have a term in common in these terms in the right hand side. We can just factor it out, which is sine x. So let's factor out sine x out. So we're going to say that the integral of cos x in sine x dx is equal to sine x. Let's open the bracket in sine x minus 1, close the bracket, plus c. So therefore, the integral of cos x in sine x dx is equal to sine x, open bracket, in sine x minus 1, close the bracket, plus c. All right. Yes. Thank you very much. Please keep watching, keep practicing. And if you have not subscribed to our YouTube channel, please do that. All right. See you next time. Thank you.